Hello everyone. In this video, we will explain the point of intersection of a line and a plane in three-dimensional geometry. Based on that, how to measure a distance of a point from the plane measured along another line. Measured along another line. So now I'm going to explain the point of intersection of line and a plane in three-dimensional geometry. So here consider a line L in symmetry form x minus x1 by L equal to y minus y1 by M equal to z minus z1 by N. And a plane phi ax plus by plus cz plus d equal to 0. So here you can see the figure. This is the plane phi and the line L. Line L. So plane passes through the point x1, y1, z1. Line passes through the point x1, y1, z1. Okay. Now suppose line meets the plane at some point Q. Suppose line meets the point at Q. So here I'm writing the process. Suppose L meets phi at some point Q. Now we need to find out what are the coordinates of Q. For that, we have to take a general point on L. So this is a ratio. So assume this is equal to T. So any point on L, any point on L, any point on L is assume that as a Q, which is common to both line and plane. So this is equal to, you see, equating the first and last, you will get x1 plus LT, comma, second and last, y1 plus MT, comma, z1 plus NT. Now, for some value of T, this point also lies on the plane for some value of T. So in order to find out a particular point which is common to both a line and a plane, we need to substitute this point in the given plane. So substitute Q in pi. We get just substitute this point, general point in the plane, A into, see here x1 plus LT, x coordinate, plus B into y1 plus MT, plus C into Z1 plus NT, plus D equal to 0. We need to find out the value of T. This implies after simplification, you see, sending AX1, BY1, CZ1 that side and plus D also. So we get T equal to minus of AX1 plus BY1 plus CZ1 plus D whole by the what is the coefficient of T? LA plus MB plus MC. So this is the value of T which we got after substituting general point in the plane. So now substitute this value. Substitute value of T in Q. So there ends the matter. So we got the point of intersection of line and plane. So how do we apply the above concept, that is point of intersection of line and plane in measuring distance of a point parallel to another line? Here you see the second one is the distance to measure the distance of the point P x1, y1, z1 from the plane pi parallel to the line. This model is important. Parallel to the line whose DRS are given, or they may give direct line also. They may give direct line, which means that according to the given line, we have to measure the distance of the point from the plane. The distance of the point from the plane can be measured in any direction, but we need a unique direction. So that unique direction is decided by given line. So here, suppose this is the given point P. This is given point P x1, y1, z1. Now suppose the given line L is this. This is the L, right? So we have to measure the distance along this line or parallel to this line. Then we have to draw a line passing through given point, So this is a line parallel to given line. Parallel lines will have same set of direction ratios. Parallel lines will have same set of direction ratios. So now, what are the direction ratios of this line? The direction ratios of this line are same as of given line. The given line DRS are L, M, N. So here also L, M, N. So now we need to write the line passing through P. Line through P. And parallel to L. And parallel to L is x minus x1 by L equal to y minus y1 equal to z minus z1 by n. X minus x1 by L equal to y minus y1 by m equal to z minus z1 by n. You take this is equal to t. So what we have done in the first phase, as t is, we have to do the process. So here we need to find out the point Q. So now find Q using the above process. The above process. That's all. Now I will solve previous JEE questions based on these two concepts. So here are a few questions based on these concepts picked from previous JEE. See here, the distance of the point P 3, 4, 4 from the point of intersection of line joining these 2 points and the plane. The distance of the point P from the point of intersection of line and plane. So now we need to write what is the equation of line. So line QR line is x minus first point is 3, minus 4, minus 5. So equation of line passing through 2 points. X minus 3 by direction ratios 2 minus 3 minus 1 equal to y plus 4. You can take first point or second point. Direction ratios, just subtract q coordinates from r coordinates. Minus 3 minus of minus 4 plus 1. Z minus 5 minus of minus plus here whole by the direction ratios are 1 minus of minus 5 6. So this is the equation of line L. Now we assume this is equal to something. So any point on L is S equal to, you take the general point minus t plus 3, t minus 4, 6t minus 5. Now substitute this point in the plane. Substitute in the given plane. In the given plane, we will get the value of t. So here 2 into minus t plus 3 plus t minus 4 plus z coordinate 60 minus 5 equal to 7. This implies this is minus 2t and this is 7t, totally 5t. This is 6 minus 4 plus 2 and this is minus 5, so minus 3. Sending that side, you will get 10. This implies t equal to 2. So now what is point of intersection of line and plane? So therefore, S equal to, S is the point of intersection of line and plane. S equal to minus 2 plus 3, that is 1. 2 minus 4 minus 2. This is 12 minus 5, 7. Now they are asking the distance of this point S from P. So we need to find out the value of PS. So the distance between P and S equal to 3 minus 1 whole square is 4. Next 4 minus of minus 2, that is 6 square 36, and 4 minus 7, that is 3, 9. So this is equal to 7. So only you have to remember that, take a general point on the line, substitute in the plane, you will get the point of intersection of line and plane. Next question. Here this is the mixed bag. Let Q be the mirror image of the point P101 with respect to the plane. So first we need to find out the mirror image of this point P with respect to the plane. So here let Q equal to, assume alpha, beta, gamma. So now apply the mirror image formula. Alpha minus here 1 by x coefficient in the plane 1, beta minus 0 by y coefficient is 1, gamma minus 1 by z coefficient is also 1. This is equal to, we want to find out the mirror image. So minus 2 times of, substitute the point P in the plane, 1 plus 0 plus 1 minus 5 by a square plus b square plus c square, that is 3. So this is equal to, here this is minus 3, minus of minus plus 6 by 3, that becomes 2. So therefore, the point Q equal to equating first and last. So you will get alpha value 3 and beta value is 2 and gamma is also 3. So we got the point Q, that is 3, 2, 3. Now continue the next line. If a line L passing through this point and parallel to the line PQ So here what is the equation of line L? Line L is passing through the point 1, -1 and -1 and parallel to line PQ. Parallel to line PQ means it is simply nothing but normal to the plane S. Normal to the plane S. So both are same, right? Because P is the image of Q with respect to the plane. So which means that PQ must be parallel to normal of the plane. So here equation of L is x minus 1 by, what are the DRS of normal to the plane? 1, 1, 1. So here 1, y plus 1 by 1. That's equal to again z plus 1 by 1. So this is the equation of line L. Now we need to find out the point of intersection of this line L with respect to the plane S. So assume you take this is equal to some t. Right. So therefore any point on L is meets the point at R, plane S at R. So R is, so any point on L is t plus 1, first and last. Y coordinate is t minus 1, z coordinate is t minus 1. Substitute in plane S. Substitute in S. We get t plus 1 plus t minus 1 y coordinate plus z again t minus 1 equal to 5. So this implies you will get 3t equal to 6, implies t equal to 2. So therefore the point R we got 3, 1 and 1. They are asking what is QR square. Hence QR square equal to distance, square of distance of between Q and R. 3 minus 3 becomes 0. 2 minus 1 whole square, that is 1. 3 minus 1 whole square, that is 4. So this is equal to 5. So here we have applied the image of a point and point of intersection of line and plane. So it is a mixed bag question, means two concepts mixed in one question. This is the plane and a point is given, that P is the point and Q is the image. So joining these two, so clearly this is perpendicular to the, plane. So which means that parallel to normal of the plane. So this is parallel to normal of the plane. Parallel to normal of the plane. I or yes here. Now moving to next question. the distance of the point. See, this is the distance of the point. This model is important. The distance of this point from the plane measured parallel to the line. Measured parallel to the line. This is the second concept which I have explained earlier. So now we have to take that a line passing through -1, 9, -16. So line through -1, 9, -16 and parallel to given line. Parallel to given line. Only the way of asking question is different, but the process is same. So here is x plus 1 by, what are the DRS of given line? 3, 4, 12. So by 3 equal to y minus 9 by 4 equal to z plus 16 by, just a minute, here the given line is not in standard form. The given line is not in standard form. So we have to observe very clearly. So this, by rewriting, it becomes y minus 2 by minus 4. So here you write minus 4. Z plus 16 by 12 equal to something. Right. So now we need to find out where this line meets the plane. Any point on L, any point on L is Q. This is 3t minus 1 minus 4t plus 9, 12t minus 16. Substitute in L. Substitute in given plane pi. So substituting in the given plane, we get this is the plane equation. So 2 into 3t minus 1 plus 3 into minus 4t plus 9 minus of 12t minus 16 equal to 5. So observe the diagram also. So this gives us, this is minus 12t minus 4t minus 12t minus 12t 3 times minus 24t, and this is 60, so minus 18t, and this is minus 2 and 27, 27 plus 16, 43, 43 minus 2, 41, bringing this side you will get minus 36. So we get t value is 2. So we got the coordinates of q by substituting the value of t. Therefore q equal to, substitute here, we get 3 to 6 minus 1, 5, minus 8 plus 9, 1, 24 minus 16, 8. So these are the coordinates of q, where the line through P and parallel to given line meets the plane. So therefore, they are asking what is the distance of that point, means what is the PQ distance. So now PQ equal to, this is the point P. So 5 minus of minus 6, 6 square 36. And next 1 minus 9, 8 square, that is 64. And this is 24 square, 576. That's equal to root over 676. That's equal to 26. So this is another mixed bag question asked in January 2023. Let the line intersects the plane at some point P. So first we need to find out the point P. Okay, well, suppose line meets the plane. Let L meets, let L be meet pi at some point. You can say R is also okay. Yes, you can say yes. So now what is any point on L? Any point on L is S equal to, assume this is equal to C T. So now you can write 2T plus 1 minus T minus 1 T plus 3. Now in order to get the point of intersection of line and plane, we need to substitute the general point. Yes, sir. So substituting in pi. Substitute in pi. We get, here this is the plane equation. So 2 times of 2t plus 1 plus y coordinate minus t minus 1 plus 3 times of z coordinate t plus 3 minus 16 are equal to 16. So this gives us, this is 4t and 3t, 7t and 1 minus t. So total is 6t. Here plus 2 and plus 9, 11. 11 minus 1, 10. 16 minus 10 is nothing but 6. So we get t value is 1. So therefore, the point of intersection of, let the line intersects the plane at the point P. Okay, here they have given already P. So this is nothing but P. These are the coordinates of P. So therefore, P equal to, substituting T value, you will get 3 minus 2 and 4. Now, let the point Q be the foot of perpendicular from the point R 1 minus 3 on the line here. So this part is over. Part 1 is over. Now part 2. Part 2. We need to find out the foot of perpendicular from a point on the line. So here the given line is L, and we need to find out the foot of perpendicular from R on the line L. You take any point on the line, general point, any point on the line, same as of previous one, that is 2t plus 1, comma, minus t minus 1, t plus 3. So you are learning both the concepts, that foot of perpendicular from a point on L. Now clearly RQ is perpendicular to L. So RQ is perpendicular to L. So therefore, two lines are perpendicular if and only if product of their DRS equal to 0. So this implies, what are the DRS of RQ? DRS of RQ are 2t into line DRS are 2 minus 1 1, so into 2 plus minus t minus 1 minus of minus plus 1, so that is minus t. Line DRS next one is minus 1 plus t plus 3 minus of minus t plus 6 into 1 equal to 0. So we will get the value of t. Here this is 4t plus t 5t and plus t 6t. So 6t plus 6 equal to 0 implies we get t equal to minus 1. Therefore, we got the coordinates of q, that is foot of perpendicular from R on the line. So q equal to, substituting t equal to minus 1, this is minus 1 and this is 0 and this is 2. So we have all the coordinates. That one point is P, this is P and Q, and what is point R? Let Q be the foot of perpendicular from R. R is already there. Now what they are asking, alpha is the area of triangle PQR. So this question consists of three parts. One is point of intersection of line and plane. Another one is foot of perpendicular from a point on a plane. And the third one is finding area of triangle in three-dimensional geometry. So now what is the area of triangle PQR? So alpha equal to area of triangle PQR equal to half of modulus of PQ bar cross PR bar. This is the formula for finding area of triangle in three-dimensional geometry. Okay, so this is nothing but simply that cross product of two vectors and taking magnitude. So half into magnitude of PQ vector. What is PQ vector? This is P and this is Q. So 3 minus of minus, here I JK. So PQ vector is 3 minus of minus 1, that becomes 4. Minus 2 minus 0 minus 2. 4 minus 2, 2. And what is PR vector? What is PR vector? Subtract R coordinates from P. 3 minus 1, that is 2. Minus 2 minus of minus 1, that becomes minus 1. And this becomes 7. Equal to half of magnitude of this vector minus 14 plus 2 minus 12i. Next, this is 28 minus 4, 24 minus 24j minus 4 and plus 4, that becomes 0. So this is equal to half into root over 12 square plus 24 square. So after simplification, you will get this is equal to 1 by 2 of this value is 144 plus 576, that is 720 under root. This you will get root over 180. So therefore, alpha square equal to 180. So this question is an excellent question, but it takes minimum 4 to 5 minutes. to complete the question. So here is another model based on finding the distance of a point from the plane pi measured parallel to another line. Here line is not in standard form. Observe clearly. We have to rewrite the middle term y minus 2 by minus 7. So first we will write the equation of line passing through the point P and parallel to this line L1. Assume this is line L1. So equation of line L through P and parallel to L1 is equation of line is x minus 1 by the DRS of L1 are 3 minus m. This is equal to y plus 2 by minus m. And the third one is 1. Z minus 3 by 1 equal to something. So any point on this line, any point on it is q equal to, we can write 3t plus 1 minus mt minus 2 and t plus 3. So this is the point of intersection of line and plane. Point of intersection of line and plane pi. Now this point Q lies on the plane. Q lies on L. Q lies on, not L, on the plane pi. So therefore, x coordinate is 3t plus 1. Substituting the point Q in the plane, plus 2 times of minus mt minus 2 minus 3 times of z coordinate is t plus 3 plus 10 equal to 0. Now we have to find out the value of t. So here 3t minus 3t is cancelled. So this is minus 2mt. And this is minus 4. This is minus 9. So minus 13 and plus 11. So you will get minus 2. This implies we want the value of t equal to minus 1 by m. So substituting the value of m in q, put in q, we get q equal to substitute t value here minus 3 by m plus 1 comma this mt value is minus 1. So minus of minus plus 1 minus 2, it is minus 1 minus 1 by m plus 3. Now what is given here? The distance between P and Q is given as root over 7 by 2. So given that the distance between P and Q equal to root over 7 by 2. So this implies PQ square equal to 7 by 2. So what is PQ square? Distance between P and Q. So here x2 minus x1 whole square is nothing but 9 by m square, and minus 1 plus 2, that becomes 1, so plus 1, and minus 1 by m plus 3 minus 3, again 1 by m square equal to 7 by 2. This implies 10 by m square equal to, sending 1 that side, you will get 5 by 2. So just after simplification or by cross multiplying, you will get m square equal to 4. So m equal to plus or minus 2. As we got here 2 values for m, that's why they are asking what is modulus of m. So therefore, modulus of m equal to only 2. So this is a very good question based on distance of a point measured parallel to a line is given, asking the value of parameter. Here is another question asked in February 2023, SIP 2. The point of intersection C of the plane and the line joining. So here the question they have asked in different way, but the intention of this question is point of intersection of line and plane. Here you see the point of intersection C of the plane and the line L divides the line segment AB internally in the ratio K is to 1. So definitely the point of intersection of line and plane will divide the line in some ratio. So here this question can be solved in 2 ways, either by finding the point of intersection of line and plane, or you find the point which divides line segment AB in the ratio K is to 1 and substitute in the plane. Both are same. So we'll do the second option. So here this is line segment AB. A is minus 3, minus 6, 1. And the B point is 2, 4, minus 3. So a point C divides in the ratio K is to 1. So what are the coordinates of C? The C coordinates are 2K minus 3 by K plus 1. We don't know whether it divides internally or externally. If K is positive, division is internal. If K is negative, division is external. So here this is y coordinate is 4K minus 6 by K plus 1, and z coordinate is minus 3K plus 1 whole by K plus 1. It lies on pi. It lies on pi. So therefore, you just substitute this point in the plane 8 times of 2K minus 3 by K plus 1, and y coordinate is 4K minus 6 by K plus 1, and z coordinate is minus 3K plus 1 by K plus 1 equal to 0. So now it is a simplification part. So we just need to simplify this expression. This implies, see, anyway denominator is same, sending that side, you will get here 16K plus 4K minus 6K What is the constant? Minus 24, minus 6, and plus 2 equal to 0. So after simplifying this expression, you will get k equal to 2. Hence, what are the coordinates of C? C equal to, substituting here, you will get 1 by 3. And substituting 2 here, 2 by 3 minus 5 by 3. Even if you try to find out the point of intersection of line and plane, means finding the line equal to t, any point on the line, and substituting in the plane, you will get the same coordinates. So we got C. So first part of the question is over. What is the second part? If A, B, C, where mod A, mod B, mod C are coprime, which means that you should not multiply any number. They are coprime means GCD of these three numbers after taking modulus must be 1. Are the direction ratios of perpendicular from C on this line? Again, you see this line is not in standard form. So you must write that this is x by minus 1. So here this is the point C, 1 by 3, 2 by 3, minus 5 by. Just in order to confuse, they have given the ratio here case 1. Suppose the foot of perpendicular from C on the line L is D. So now what is any point on the line? Here the line is, this is the line L, x minus 1 by minus 1, y plus 4 by 2 equal to z plus 2 by 3. You take equal to some t. So the coordinates of D are now minus t plus 1, comma 2t minus 4, any point on the line, comma 3t minus 2. So now you observe clearly that CD is perpendicular to the line L. CD is perpendicular to line L. So therefore, product of DRS of line CD and the given line is 0. So what are the DRS of line CD? Subtract 1 point from the other point. So minus t plus 1 minus 1 by 3. That is minus t plus 1 minus 1 by 3 into minus 1 plus 2t minus 4 minus 2 by 3 into 2 plus 3t minus 2 plus 5 by 3 into, here it is 3, equal to 0. We need to calculate the value of t. Here you see this is minus of minus plus t, and this is 4t, 5t, and this is 9 into t. So totally 14t. After simplification, this implies you will get this is 14t minus 11 equal to 0. So t equal to 11 by 14. Now we need to find out what are the DRS of line CD. So DRS of line CD, these are the DRS of line CD. Okay, so therefore DRS of CD means the perpendicular CD or DC, whatever it may be, no problem at all. Or this is minus t plus 2 by 3, comma This one is 2t minus 14 by 3. And this is 3t minus 1 by 3. Substitute t value here. That is minus 11 by 14 plus 2 by 3. This is 11 by 7 minus 14 by 3. And this is 33 by 14 minus 1 by 3. We need to simplify this. So here I have simplified these numbers. After simplification, we got like this, or you multiply with 42. So you will get minus 5 minus 130 and 85. This is 42. So this is A and this is B and this is C. Okay, let me check it once again. So here these are all divisible by 5. So let us remove the common term because their GCD must be 1. So minus 1, it is minus 26 comma 70. So this value is A and this is B and this is C. So they are asking what is the modulus of A plus B plus C. Modulus of A plus B plus C. Direction numbers means proportional to DCs. So this is modulus of minus 1 minus 26 plus 17. This is equal to 10. Well, there is another question. Here you see a line L with DRS. They have given little clumsy. Is perpendicular to the line with the DRS of another two lines whose DRS are given. If the point of intersection of this line and the plane is alpha, beta, gamma, then they are asking what is alpha plus beta plus gamma. So these are the DRS of line 1 and these are the DRS of line 2 and these are the DRS of line 3. So given that L1 is perpendicular to L2. So therefore dot product of DRS is 0. Therefore A into 3 minus 4A into minus 1 minus 7 into 2B equal to 0. You will get one equation. This implies this is plus 4A and plus 3A, 7A, 7, 7 cancel. So you will get A minus 2B equal to 0 or A equal to 2B. So this is one relation between A and B. Now see, L1 is also perpendicular to L3, which means that L1 is parallel to L2 cross L3. So again applying the dot product of DRS of the lines is 0. So here A into B minus 4A into A and plus 14 equal to 0. So here we are getting a quadratic. You can substitute A equal to 2B or B equal to A by 2. So B equal to A by 2, substituting here, B equal to A by 2 minus 4A square equal to minus 14. So we will get this is A square by 2 minus 4A square. So minus 7A square equal to minus 14 into 2. This implies a square equal to 4. So therefore, we got a equal to plus or minus 2. Anyway, they are not using a alone. Everywhere they have used only a square. So a square equal to 4. So what is b value? Therefore, b square equal to a square by 4. This is equal to 1. Now, we will write this equation. Assume this is a line 4. So what is the line 4 now? Line 4 is x plus 1 by a square plus b square is nothing but 5 equal to y minus 2 by a square minus b square is 3 equal to z by 1. Now we need to find out point of intersection. So this is equal to assume some t. So any point on L4, any point on L4 is P 5t minus 1, 3t plus 2, comma t. So it also lies on the plane. Put in pi or substitute in the given plane. This is the plane pi. We get. So here x coordinate is 5t minus 1 minus 3t minus 2 and z coordinate is t equal to 0. So we will get this is 5t plus t 6t minus 3t. So you will get 3t equal to 3. So this implies t equal to 1. Therefore, the point of intersection of line and plane is P equal to, substituting 1 in P, you will get 4, 5, comma 1. So these are the alpha, beta, gamma. Hence we got the answer. So you please subscribe to this channel. It is very useful to so many students to learn the concept perfectly, and I am providing solved examples of previous JEE main questions.